Assalamualaikum and hi, my name is Muhammad Habib Rosman, Nometric DD220092. We'll be presenting about background project. For the background project, we choose piping and heat tracing. So piping and heat tracing is vital as it used to transport both medium, which is fluid, and gases. So for industrial purposes, we commonly use steam, and for domestic purpose, we use water. Heat tracing is commonly used for colder region to prevent frosting of the substance flowing in the pipelines. So for the details, we will focus on the insulator. So for the insulator, we have various types and material that consists different thermal conductivity. So for the associated heat transfer problem, the conductivity and the conduction is included in the process. For conduction, it occurs between the fluid, pipe wall, and the insulator. And for convection, the heat transfer to the outside surrounding.
Assalamualaikum. My name is Ahmad Solah. So I will continue with part theory and method. So I will explain about the heat tracing in pipe. So heat tracing meanings that maintaining temperature of stagnant fluid by replacing the heat loss through the thermal insulation. And then also heat tracing will never heat a flowing line, and if you lose your heating medium, you will lose the temperature in the downstream for the equipment. And then this is part for heat theory for heat tracing in piping. So theory for piping is always heat always be transferred from a hot medium to a cool medium. And also pipe tracing and heat tracing is commonly used to ensure that process for the fluid or material temperature. It also can be divided into broad class, which is electric and fluid. Fluid heat tracing system utilize heating media at evaluate temperature to transfer heat to a pipeline. And for the process of the heat loss in insulated pipe, heat loss again take place from a pipe carrying hotter, colder fluid than ambient temperature. Also, insulation reduce the heat loss to the surrounding, and then heat loss depend upon number of factor like insulation thickness, ambient temperature, also wind speed. So I will continue for the heat conduction in piping, which is shape cylinder and sphere. So heat is lost from a water pipe to the air outsider in a radial direction, and thus heat transfer from a long pipe as steady and one dimension. So the temperature of the pipe depends on the direction only, which is can be expressed as T equal to T R. So a long cylindrical pipe or spherical shell, which is specific inner and outer surface temperature T1 and T2. In spherical shell with specific inner and outer surface also temperature T1 and T2.
Assalamualaikum. My name is Muhammad Fikri Azim bin Kamaruddin, and right now I will start my presentation with calculation. So our group are going to calculate about the heat loss through an insulated steam pipe. So the first thing that we are going to do is we are going to take out the important information such as temperature, diameter, length, thermal conductivities, and H. So next is we are going to find the area. So for area we will use 2 pi RL to find the answer. After that, we need to find individual thermal resistance. There are 4 different thermal resistance that we are going to find, which is R convection, R pipe, R insulation, and R convection 2. So for R convection, the equation is 1 over H1 A1. And for R pipe, we are going to use formula ln bracket R2 over R1 over 2 pi K1L. And then after we finish calculate for individual thermal resistance, then we need to combine all those answers to get R total. Next is we are going to find the steady rate of heat loss. The formula that we're going to use is Q dot equal to T infinity 1 minus T infinity 2 over R total. So the answer is 387 watt. So which means that every 1 meter pipe length there are going there are around 387 watt of heat loss. So next we are going to calculate the heat loss for pipe and insulation. So to know the answer, we are just simply use the rate of heat loss that we just find before this and multiply the length of pipe and length of insulation. So we are going to get the answer.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris and this Miss. I will present about this question and how to solve it using the calculation. Okay, the question is what improvement that we can do or add so we can reduce the rate of heat loss in pipes. So the solution is we add the number of insulation from 3 cm to 4.5 cm. Okay, first step is we take out all of the information they given to us. So in this calculation, we use two formula that is convection 1 over HA and conduction ln in the bracket R2 over R1 plus bracket divide by 2 pi KL. Okay, so next we calculate the area 1 and area 3. So area we use to formula area of cylinder 2 pi RL. So area 1 2 pi R1 is convert to 0.03 multiplied by 2, so the answer is 0.377 meter per square. So the A3 2 pi R3L. So R3 we use R2 plus 0.045. That is the insulation number. Okay, so the answer is 1.005 meter square. Okay, next is for individual thermal resistance. So as you can see, convection and conduction. So for formula R convection is 1 over HA. So for R conduction is ln in the bracket R2 over R1 close bracket divided by 2 pi KL. Okay, as you can see, and the RI and the R1 is same result as the past calculation. That is, RI is 0.0408, and R1 is 8.2 multiplied by 10 to the power of negative 4, 0 Celsius over watt. So what the focus is for, we focus on the R isolation because we just adjust the insulation value. So we just add along 8.0 over 3.5 divide by 2 pi in the bracket 0.07 multiplied by 2. So the answer is for our insulation is 0.94 degrees Celsius over watt. So for our convection two, we have adjust the area 3. So the new answer is 0.066 because we used to 1 over 15 multiplied by 1.005. Okay, next we calculate the R total, that is RI plus R1 plus R2 plus RO. So the answer is 1.048 degrees Celsius over watt. So we can see the steady rate of heat loss is 305.34 per meter pipeline. So the heat loss for given pipeline is the pipe is 0.25, while the T insulation is 287 degrees Celsius. So as we can see, the for the T insulation, we already reduced the heat loss from the previous, so it's near to the 305.34, and the heat loss does a little, so the heat uh, in the installation is 287 degrees Celsius. So we succeed to reduce the heat loss. Thank you.
For discussion, there are new finding and improvement to reduce the heat loss. The first new finding is we know that every material has its own heat loss and thermal coefficient. For example, the thermal conductivity for cast iron is 80, and we also know that we cannot simply add the thickness of insulation to find the minimum rate of heat loss, because after a few attempts, we are finally able to find the suitable thickness of insulation, which is 1.5 larger than original thicknesses. So for the improvement, to reduce the heat loss, we can use the different type of insulation as material, such as fiberglass or foam, because it have better thermal qualities. Next, temperature variation. We can reduce the heat loss by minimizing the temperature differential. And lastly, heat loss can be reduced by increasing the thicknesses of insulation.
So for conclusion, the project highlights all the importance of the insulation in piping system. For students, they can get a better understanding in the concept and finding a trustworthy resources. And for professional, the calculation gives the clear insight to solve all the problems due to the rapid expansion of the technology and determine the best material for insulation for insulator. For recommendations, for the problem discussed, the overall efficiency can be improved by increase the thickness of the insulator, as well as picking a material which consists a low thermal conductivity to increase the efficiency of the insulation. That's all for me. Thank you.